Hello, this is Mr. Waters again, and here's another example. And this is one where we're going to be analyzing the given ellipse equation and then graphing it. And we're going to be starting out with an equation like this: 4x squared plus 3y squared plus 8x minus 6y is equal to 5. So we look here and we see, oh goodness, the equation is not in the vertex form, it's in the standard form. Okay, so that means we have got to put it in vertex form before we can begin to analyze it. Now, by vertex form, we mean something like x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1, something like that. And then also remember, to be analyzing it means we're going to find the focal points, the vertex, the center, and then, as it says there, we are going to graph eat. Okay, so what are we going to do to put this in the vertex form? Well, what we've got to do is we've got to complete the square twice. Once for the y squared and the y linear part, and once for the x values. So we gather the x's and the y's together. 4x squared plus the 8x plus 3y squared minus the 6y equals to 5. Now normally we'd go ahead and we'd clear the constant to the other side of the equal sign, but it's already cleared. So we'll just leave the 5 where it is. In order to conveniently complete the square, we want to get that constant 4 away from the x squared. So we're going to divide this entire 4x squared and 8x chunk by 4. Going to divide that out, and it's going to give us 4 on the outside plus 2x, and then we're going to leave a blank there where we're going to add the value to complete the square. Here we're going to divide the y parts. We're going to factor out a 3 so that the coefficient on the y squared is 1, because that makes it easier to complete the square, minus 2y, because 6 divided by 3 is 2. Put a blank in, close the parentheses, equal 5. Now we think, what do we need to do? What do we got to add here to complete the square? Well, for this one, half of 2 is 1. 1 squared. For this one, half of 2 is 1. 1 squared is 1. So we're going to add 1 to complete the square there. But since the 4 is on the outside, we're really adding 4 times 1, which is 4. So we're going to add 4 to the other side to totally balance that. Into the y squared, we're going to add 1 to complete that square, because half of negative 2 is negative 1, and negative 1 squared is positive 1. But again, we're not really adding, we're adding 1 inside the parentheses, which means that we're adding a total of 3 times 1, or 3. So we're going to add 3 to the other side to balance it out. So now we can kind of simplify all of it. Factor this part. The x squared plus 2x plus 1 factors into x plus 1 quantity squared, and there is our coefficient of 4 plus 3. Okay, the y squared minus 2y plus 1 factors into y minus 1 quantity squared, and over here 5 plus 4 plus 5 plus 4 plus 3 is equal to 12. Now that's getting a little closer to what we want, but remember that in our vertex form it equals 1, so I'm going to divide everything by 12 here. Divide everything by 12 here, and that's those, luckily the 4 cancels out, leaving a 3. So we've got x plus 1 quantity squared over 3 plus, and then we reduce this. 3 divides a 3 out of the 12, and we've got a 4 So that reduces to y minus 1 quantity squared over 4. 12 divided by 12 is 1. Aha! So now we've got our equation in shape to analyze. And so we can now look at that and we can see that, okay, the larger value, the a value, is under the y. So this is a vertically oriented ellipse. And so that means, roughly speaking, it's going to have this shape here with the foci oriented vertically on the major axis. This will be the A, and this will be the A, and this will be the B, and this will be the B. So right off we can see, oh look, here is the H value and there is the K value. So we can see that the center point is going to be -1, 1 when we graph it. We can see that the A number, I'm going to write it here, the A number is the square root of 4, which is 2, and the B number is the square root of 3, which is approximately 1.7. Okay, so that's going to help us when we graph. Now C squared is going to be equal to A squared minus B squared, so that's going to be 4 minus 3. Remember, we're going to use the A squared number here and the B squared number, and that's equal to 1. Scrolling down a little bit, C squared is equal to 1, and so C is equal to the square root of 1, which is plus or minus 1. Very good. Now we can go ahead and we can begin to make our graph. And this will help us picture what the other values are, the vertices and the focal points, and get the coordinates of those. So first off, the center, I'll write it, okay, the center was -1, 1. So down 1, so left 1, up 1 is the center. Okay. And the A value is 2, and it's vertically oriented, so I'm going to count up 2 and down 2 in order to find those points. So you can see that the coordinate of that vertex up there is -1, 3. And this vertex is -1, -1, right? Okay, and we're going to count over rad 3 for the other minor axis vertices, which is about 1.7, so that's approximately there and approximately there. And we can now sketch in our ellipse. It's sort of like that, kind of. Okay, so the coordinates here, we started at 1, -1, you understand. We started at 1, -1, and to get one vertex point, we counted to the right, rad 3. So that's going to be -1 plus rad 3 is the x coordinate, 1. And then we started at the center point here, and we counted to the left, left rad 3. So this vertex coordinate is -1 minus rad 3, comma, -1. So here are our vertex points. We've got -1, 3. We've got -1, -1. We've got -1 minus rad 3, -1. And we've got -1 plus rad 3, -1. Okay, now the only thing we have to do left is we have to figure out where the focal points are. Well, the focal distance over here, the focal distance is 1 and positive 1, and since it's vertically oriented, that means from the center we're going to go up 1 and down 1. So we go up 1 from the center to get to there for one focal point, down 1 here to get that focal point. I'll use a different color here. How about blue? Those coordinates there, or that coordinate, is going to be -1, 2 for that focal point, and this coordinate here is going to be -1, 0. So over here, the focal points are going to be -1, 2 and -1, 0. So you can see that we are done with our analyzing. We had the equation that we started with. We produced a graph here with all of the critical points labeled, and then we wrote down in a nice organized list over on the right here our critical points. And that'll do it. Thank you so much.